Well, thanks, guys. Thanks for having me on here. Glad to be part of this elite group of people presenting. My name is Matt Casey. I'm the CEO of RST CleanTech, and I wanted to do a presentation here about panel soiling. As we all know, soiling, dirt on the panel is one of the major losses when we look at operations and the performance of solar arrays. So, we're in a unique position at RST to be able to take a look at this, and we wanted to share some of the insights that we have from the field. So I'd like to talk about what's going on in the market, the challenges that we're seeing in the industry, and obviously a little bit more about RST. Just a basic background about RST. We're an automated solar panel cleaning technology. We have almost no moving parts. We're controlled by a cell phone app. And as a result, we can basically choose when we want to clean the panels. The result is that we can eliminate soiling losses basically entirely. So when we're looking at performance data for these solar arrays, we can say, hey, what was the soiling rate? How much of the losses were attributed to soiling? The other advantages of RST are that we can protect the warranties. We clean at night, not during the day, so we're able to reduce that thermal stress on panels. And we use filtered water through electrolysis, and it's at low pressure. So by cleaning often, you don't get that buildup of dirt. We're able to essentially keep these panels clean all the time. And this leads to our company motto, which is minimizing dirt and maximizing production. The company cleans about 2 million panels a day. We've been doing it about 10 years. In Israel, we're installed, as I understand it, on about 35% of all the projects in the country currently. We've been averaging over the last year and a half through COVID about a megawatt a day of installations. We're growing rapidly as the market matures and understands how much production is being lost from soiling. RST is providing that solution for customers to help maximize production. So I think the easiest way to really talk about this is look at a case study. In this study, this is a farm. It's a 1.1 megawatt farm in the Central Valley. We installed RST on one inverter's worth of panels, and you can see that in the bottom right. Those panels seem a little cleaner. It was on the full bottom row and half of the top row of that bottom right array. You can see here, this is some pictures about 6 months into the study. Our system is on the bottom row on the left picture. You can see the real difference between the RST panels and the ones that aren't. Also wanted to point out, with all the birds that were perching on these panels, our system was able to keep a lot of that bird excrement off through consistent washing at night. So here are the general inputs for the study, and we're going to pick on PV watts as an energy estimate to give you guys a sense of where these models are going astray. If you took a look at this, they would produce, PV watts would say that there's a 1622 production factor, and that you'd be seeing 1.796 megawatt hours for the year. And when you dig into where they're putting in their assumptions for losses, they're assuming about a 2% soiling loss and 14.08 total losses. But this is what happened in reality. The first year of the production of this facility, they did not reach 1.796 megawatt hours. They're at 1.67 megawatt hours, which is 7.5% less than the model. The owner of the site, a dairyman, he was cleaning it, I think, three times a year, and increased that number of cleanings with basically spraying water on the panels with his water truck. So he's spending more and more time trying to basically get the production back to what it was originally promised to him by the developer. So at the end of the day, he's spending about $10,000 in cleaning costs, money that he wasn't planning on spending, and he's still not getting where he needs to be. So we put we put RST on one of the inverters, and this is sort of the basic data here. What you're seeing is the relative improvement of the inverter with the RST system on its panels compared to the average of the other inverters at the site. So what you're seeing here is how much better the inverter with RST was doing compared to the other inverters at site. So essentially, all this is additional production that we're able to get because we're cleaning on a daily basis out there. A few things to take away from this. In February and March last year in Central California, there was quite a bit of rain. And when those rain events occurred, the difference between the production of the RST inverter and other inverters really dropped, but it didn't drop all the way, it dropped 3 to 5%. And there was a general upward curve. So we know this about soiling on panels. If it's not a heavy rain, what you'll see is a sort of cementation of the dirt on the panels. Eventually, the owner decided to start using this water truck by spraying on the panels. This is a very common practice in the Central Valley. It uses a ton of water, about 10,000 gallons for a 1 megawatt, and it's it's what the dairy farmers do. What we're finding in this study and others is that it really does keep the soiling down, but it also still doesn't reduce the soiling completely. You're still at around a 10% loss. Now, through the rest of the year, the owner got busy. He started bringing in someone to brush clean, but interestingly, a month later, he'd be back up at a 25% loss. So you can see here that the soiling rates were getting up close to 1.5% a day in September, October of last year. This slide here, you can see the green line. That is where the energy estimates are assuming the soiling loss is. So you can see there's a real big disconnect here, and that's a problem. Over the 233 days that we did this study, with all the cleaning that was done, our system at RST still improved the production 12.23%. So, I mean, what are we talking about here in terms of real soiling production losses? Is it 2%? Could it be more than 14%, which would be all the losses in the PV watts model? These are open questions that I think as an industry we need to have a little better sense of, especially when we're looking at these models. Here's another example. This one's in North LA. We just did a full year assessment on this site where we installed on a rooftop there. There's 4 sections there we installed in one of those sections. You can see that the PV watts model projected a 1524 production factor at 14% losses, but we ended up with 1743 production factor, which is 14.4% better production. So there's an interesting story here. I think there's a lot that needs to be unpacked, but we're overcoming not only the soiling losses, but all the losses in the system. It suggests that the original energy estimate may be problematic. Here's a third study that we did. This one is in downtown LA. What's interesting here is that at one point we achieved 40% improvement in production compared to the inverters that didn't have RST. Had this owner not been washing the panels twice during this case study, where would his losses have been? It certainly would have been at 14%. So look, the challenges in the industry, and there's been a lot of talk about underperformance. A lot of that's being driven by soiling losses. All the soiling losses, they're greater than what's being put in the model, but are they greater than all the losses in the model? Look, developers and EPCs that sell distributed solar to customers, they're much more focused on the building, not the long-term performance. They usually leave the owners to maintain the system, and they're not educated about what's required in order to optimize their system. Often these owners are paying a lot more money and spending a lot more time than they want. Projects are typically sold as a dollar per watt, but if we really want to get people educated and thinking about what the value of a project is, we need to talk about cost per kilowatt hour. At the end of the day, I keep on saying this to a lot of customers, as an industry, we're selling a 6-pack with only 5 cans. We're really selling something that doesn't perform up to what we say it's going to perform. A lot of this is being driven by just traditional cleaning. Traditional cleaning really hasn't been a great solution for people. I mean, look, once you clean, the money's gone. And look, if there's a windstorm or something a few days later, you've really lost all that money. Often the cleaning is being done reactively, not proactively. And you're often spending money just to get up to where you thought you would be. There's other challenges here. So cleaners don't show up when they need to because that's when everyone else needs them. There's a lower margin to work with and higher turnover in panel cleaning. So a lot of these companies come and go. Obviously, having people out at the site creates liability. You can crack panels and so on and so forth. And then, of course, we're talking about long-term warranties. A lot of these assets, you can't just do it at night. Obviously, their insurance wouldn't cover them to be on rooftops at night. So they're cleaning during the day, and that can put thermal stress on the glass. And most of these panel manufacturers say that will void the panel warranty. So as an industry, we do need to come up with a better solution, something that's lower maintenance, really reduces the soiling losses, protects warranties, reduces liability. Obviously, we want it to pay for itself and allow people that manage these assets to not be hassled and really focus on what they're good at, like at a dairy, milk and cows. So, obviously I wouldn't be here if I didn't think we could provide that solution as RST. We're seeing that, and that's why we're growing as quickly as we are. Here's a great example. This one is out near Visalia. This is one day after the alfalfa harvest and the fields all around this facility. The panels look absolutely clean, and we're talking about clouds of wheat and dust in the air. So we can reduce the soiling losses here and really achieve performance for customers. Here's another example. You can notice that the top panels are dirty and it's crying out SOS. It needs help. This owner is extremely happy. We've reduced the true-up bill completely for this residential owner. And for our case study, here's a picture of this project just, about 4 weeks ago. We haven't touched this system in 6 months. It looks absolutely clean. It's performing. The owner is super happy. So, as a company, we're seeing this, a lot of customers, a lot of assets, a lot of underperformance. Everyone's pretty angry. A lot of people are angry out there. We're coming in, we're able to provide a solution that really does improve production for people and protect their warranties. And, this all starts with the energy estimates and what we're telling customers. We do need to get stronger about this. We do need to understand soiling losses. And as we grow, when we're more accurate, when we can provide solutions that we promise, obviously that improves relationships and helps the industry with a good name. That's my presentation. Thank you, guys.
Wonderful. Thank you so much, Matthew. That was great.